I have here a little addendum that I want to add to the right triangle trigonometry section for the SAT, and that is where we're going to be using our calculator in order to evaluate either missing sides or missing angles, and we refer to this as solving a right triangle. And the idea of solving a right triangle means to find all angles and all sides, but the process is just a shortened version if we only need one angle or one side, and we're going to have to use our calculator in order to do it, unless the triangle that we have is one of our special right triangles. And so, as always, if we recognize that we have a special right triangle, we'll want to try and use those proportions and those relationships in order to evaluate. But if we end up with a triangle that is not one of our specials, then we have to use our calculator in order to evaluate for the missing side or the missing angle using our trigonometric functions. And we're going to go through a couple examples here. So the first triangle that we have here on the left is a right triangle where we are given an angle and a side, but we are missing a side that we want to solve for. In our second triangle, again, we're given two sides, but this time we're trying to find the angle that is missing. And so what we're going to do for both of these is create an algebraic equation in which we want to isolate and solve for x by using our trigonometric ratios. And so the first thing we need to do is consider which ratio are we going to use. Are we going to use sine, cosine, or tangent? And so we want to consider the sides that are referenced or utilized in the problem in relation to the angle that is given. So for this angle theta of 37 degrees, we have the side that is opposite, and we have the side that is adjacent, which means for this ratio we're going to use tangent that utilizes opposite over adjacent ratio. So we'll start out with tangent of our angle theta will be equal to the ratio of the opposite side over the adjacent side. So that's kind of the structure that we're going to be using. And then what we can do is fill in the values that we know and the unknown in order to set up our equation, and then we can go ahead and solve. Well, theta is the angle 37 degrees, and our opposite side is length 25, and our adjacent side is length x. So now we have an algebraic equation, and all we have to do is isolate x in order to solve for it. So we can go ahead and multiply both sides of our equation by the denominator x so that we can get x out of the denominator and one step closer to having it isolated. And then the last thing to do to isolate x is to divide both sides by tangent of 37. So this leaves us with the expression that x is equal to 25 divided by tangent of 37. And then we can use our calculator in order to evaluate this. And we'll do that in a moment. Let's go back to the other one and write up another algebraic equation, and then we'll go ahead and plug both of these in to solve. So we'll go back to, again, looking at the sides that we have in relation to the angle. Well, this side here is the adjacent side, and here we have our hypotenuse. So since we're using the adjacent and the hypotenuse side, we need to use cosine. So cosine of an angle, theta, is equal to the ratio of the adjacent side divided by the hypotenuse side. Substituting in the values that we have, we don't know the angle theta, so that's going to be x equals 4 over 7. Now this gets a little bit more interesting. And how do we isolate x out of cosine? Well, in order to solve for an angle x, the inverse of cosine is something called inverse cosine, and or also known as arc cosine. And that's represented by the little -1 as a, looks like an exponent, but it's not an exponent. And it's saying the inverse of our cosine. And what we actually do is we do the inverse cosine with the ratio and set it equal to our angle measurement. And so by isolating x, we have to use the inverse cosine, and our calculator has a button for inverse cosine as well. So let's go ahead and get our T84 calculator and take a look at how we could plug both of these in order to solve for x. So I have my T84 Plus calculator over here, And what we're going to do is we'll solve this first one down here, x equals 25 tangent of 37. And so in order to evaluate this, we're going to have to check two things. Angles can be measured using two different methods, either degrees or radians. And we'll spend some more time talking about radians a little bit later. But you need to know that on a lot of graphing calculators, the default mode is radians. And so if you look up here on our calculator, we see that the mode is in radians. Sometimes it's abbreviated as RAD, depending on whether you're using a scientific calculator or a graphing calculator. You need to make sure that you're using the correct mode. Well, if the angle is given in degrees, we have to use degrees mode. If the angle is given in radians, we have to use radians mode. And whichever mode we're in, if we're trying to find the angle, well, that's what it's going to return the angle as, is either degrees or as radians. And so we have to make sure that we change that. And so what we're going to do is we are going to go ahead and go to the mode button, and we're going to click on that. And then when we click on mode, we want to go ahead and scroll down to where we have radians or degrees, and we're going to shift that over to degrees and press the enter button all the way down here at the bottom right, so that we see degrees is flashing, and we also can see that up at the top, degree has changed from radians. And so now we're ready to go ahead and evaluate our functions now that we're in the correct mode. So we're going to press second mode in order to quit. And then we can go ahead and now just evaluate that we're in the correct mode. So we're going to do 25 divided by, and you'll see highlighted here the button for tangent. You see right there in the middle of the calculator we have sine, cosine, and tangent. I also want you to notice above those three buttons are sine to the -1, cosine to the -1, and tangent to the -1. Those are our inverse sine, inverse cosine, and inverse tangent. We'll use those in just a minute. So here we'll type in our 37. Since we're in degrees mode, the calculator knows that this is 37 degrees, and then all we have to do is press enter. Now, a lot of times we'll get these estimate or rounded values for the side length unless we end up with something very specific. But we can see here now that we have a value for the length of the side. We know that x is approximately 33.2 units long. However long, how many decimals we want to round it to, we can, but we know it's approximately 33 units long for the adjacent side. Now let's go ahead and evaluate for the inverse cosine. So for our second problem over here on the right, we want to evaluate the inverse cosine of 4/7. Again, making sure that we're in degrees mode because we want degrees as our angle measurement. We're now instead of pressing cosine, we're going to press second cosine so that we get the inverse cosine. And then we just write our fraction of 4/7 inside there. And we evaluate it. And it gives us, again, an approximation, but it gives us an estimate for the measure of the angle. So we know that the angle x is approximately 55.2 degrees. And that's how we can use our calculator to solve for missing values of a right triangle. We want to write an algebraic expression based off of the trigonometric ratios, fill in the values that we know along with a variable, isolate the variable in order to solve. We're going to use sine, cosine, and tangent when we're trying to find a missing side length, but we're going to use inverse sine, inverse cosine, and inverse tangent whenever we're trying to find a missing angle.